In this video, I will give you a quick introduction to the magnetic vector potential. In the same way that we have in electricity, the electric field and the electric potential, we have, in addition to the magnetic field, we have the magnetic vector potential. Now, there are some differences. The electric potential is actually easier to work with than the electric field. This is a scalar function. It depends on the position, but it's a single number. In contrast, the magnetic vector potential, it's a vector. For every point in space, you will need to know three quantities, the x, y, z components of A. Now, in electricity, there was an obvious advantage to working with electric potential, which is a single one number, one quantity, versus the magnetic vector potential, which is a vector. There is no clear advantage in magnetism in working with A instead of B. Now, we know from Ampere's law that the curl of A, we know that the curl of A is equal to B, and we have the freedom in deciding what is the divergence of A, and of course, to make our lives easier, we set that quantity to be 0. Now, combining this and the fact that from Ampere's law we know that the curl of B is equal to mu naught times the current density, we get that the Laplacian of A is equal to minus mu naught times the current density. Now, this is a vector equation. You have x, y, z components on the left side, x, y, z components on the right side. If we assume that the current density goes to 0 at infinity, we have the constant mu naught over 4 pi over the volume integral, the current density. This will be a function of R source over the magnitude of R, and we're integrating over the volume current. So this is a volume integral, and I want to remind you the relative position vector R is R obs minus R source. So we're integrating over the volume, that is what includes the current density. This will be this is the current density as a function of position, and this R, remember, this R is the relative position vector from the source location to the observation location.